Hello, this is Mr. Stansbury. I'm going to take you through the notes on the unit circle. At the end of this, you should be able to say I can state and calculate units in terms of sine and cosine, and I can evaluate trig ratios. Okay, so here's the idea. With this first page here, I want you to just watch this part and don't worry about taking notes on this. Okay, this is just to kind of help you understand what's going on. Unit circle is a circle with center at 0, 0, and the radius is 1 unit. So we're saying from here to the outside here, this is all of these lengths here are going to be 1. Okay, it goes all the way out, including these here as well. Those are all going to be length of 1. And the equation of this circle here is x squared plus y squared equals 1. Again, no need to write this down. Just watch and try to understand. If P point, this yellow point right here, is any point on the unit circle such that OP makes an angle theta, that's that little theta down there, it's hard to see, measured anti-clockwise, otherwise known as counterclockwise, from the positive x-axis. So if they're saying basically if we've got this point right here and we can make it's on the unit circle, and we've got this angle right here, then we will know that the x-coordinate is going to be cosine of theta, and the y-coordinate is going to be sine of theta of this angle right here. Okay? Now, here is how that works. If you remember our good friend SOHCAHTOA, all right, if we have SOHCAHTOA is going to help us out here. If we're looking for this length right here, let's do that in a different color, easier to see. Oh, I did do it in blue over there. I'm going to keep it in blue because that's what I got underlined over there. So we're looking for this length right here. This is going to be our x value. But now if we've got an angle here, remember SOHCAHTOA, this side right here, this is the adjacent side. This side over here is the opposite side, and this side here is the hypotenuse, right? So in order to come up with this length right here, we have the angle, and we are looking for this side, but we know that this side here is 1 because it's a unit circle. So we would say, oh, adjacent and hypotenuse. Adjacent and hypotenuse is cosine. So we would say, oh, cosine of this angle, cosine theta, is going to equal adjacent over hypotenuse, or x over 1 in this case. So our x is going to equal cosine theta. Okay? Now, the y value here, this right here, that's going to be, from this angle, that's going to be the opposite side over hypotenuse. Opposite over hypotenuse is sine of theta. So to figure out what this length is, it's going to be sine, which is sine of whatever angle we get, is opposite over the hypotenuse, which in this case is 1. So that's going to just give us what y would equal. Now, let's look at this in with some examples, and I think this will start making a lot more sense. Okay? Using the unit circle, state the exact coordinates of point A and B. So we're coming up with this point A right here. We want to know what are the exact coordinates to 3, oh, I should put that on there, to 3 decimal places. We're going to go to 3 decimal places on this. So if we are looking for this length right here, because look, we can make ourselves a nice little right triangle here to go up to this point. We know that this angle right here is 42. And if we want to look, we want to try to find the x and the y coordinates, x and y. This side right here is the adjacent side. This is the opposite side. And this is the hypotenuse, which we know has got a length of 1. Okay? So what we're going to do is we say, oh, if we want to know what this x length is, that's adjacent, and we know the hypotenuse is 1. So adjacent and hypotenuse from SOHCAHTOA. The adjacent and hypotenuse is cosine. So we know that to come up with the coordinate for point A, that's going to be cosine of our angle, which is in this case 42. And then to come up with the y coordinate, that's opposite and hypotenuse, that's sine. So we would then do sine of 42. Okay? Let me show this just to help this hopefully make a little bit more sense. So sine, I kind of skipped a step in here. Sine of 42 equals adjacent over hypotenuse. So that's going to be, oh, sorry, sine of 42 is going to be opposite over hypotenuse. And the opposite side in this case is y over hypotenuse, which is 1. And y divided by 1 is not changing anything, so we can just simply write that y is going to be sine of 42. So that's why we get y is sine of 42. And then cosine of 42, cosine is the adjacent over hypotenuse. In this case, adjacent is our x over hypotenuse, which is 1. And again, dividing by 1 doesn't change anything, so then we simply get rid of that divided by 1, and that's why we know that x is cosine 42. Okay, so there's our x. Oops, there's our x, and there's our y. So we can now actually stick that into our calculator and see what those equal. So make sure, if we haven't used our calculators for a little bit, at least as far as we're talking about like with trig stuff. So what we need to do is go into mode. You need to make sure that your calculator's in degree mode. You only have to do that once. Once you know it's there, then you're good to go. So then now we know it's in degree mode, and we're just going to simply type in cosine 42, and that gives us 0.743. And then we're going to also type in sine of 42, and that's going to give us our y coordinate, and that's 0.669. 0.669. So what that means is that this length right here is 0.743, and this length right here, this distance, is 0.669. So that's the coordinate of this point up here, 0.743 and 0.669. Okay? B is the same exact idea. We're going to simply plug in cosine of 208 for the x value and sine of 208 for the y value. Stick it into our calculator and see what we get. So we do cosine 208, and we get negative 0.883. Right, and that makes sense because we're going to the left. That's the negative direction. And then to do the y, we're going to do sine of 208. And we get negative 0.469. Okay, and that's that distance from here to here. Okay? Okay, got one other thing to show you in this section, but first let's take a quick little comedy break.
Did you take a bite of the dried one? I dare you take a bite of the
All right. Let's take a look at another thing here. So we are going to fill in this following chart. These are all like important angle measures for special right triangles that we have that are going to be useful for us here in the future. So we're going to fill that in. In order to do that, we're going to help us understand this, we're going to make a little unit circle here with all the degrees, 0, 90, 180, 270, and then we can, we could put in all these other degrees, but we're going to do a little shortcut so that we can keep this a little bit on the shorter side. Okay, so when we're going to look for sine of, we're going to just do the fill in the sine part here first. So we're going to do sine of 0 degrees. So here's 0 degrees. Sine, if you'll remember, is the opposite side over the hypotenuse. Since this is a unit circle, this length here is 1, right? And then that means if we're right here, there is no height on this, so that means it's going to be 0 over the hypotenuse, which is 1. So we simply, let's get this back right here. There we go. We get 0 over 1, which is simply just 0. Okay? And then we're going to figure out what opposite over adjacent. opposite over hypotenuse is for 30 degrees, 45 degrees, 60 degrees, and then we'll look at 90 degrees. And then the good news is we don't have to look at all of these. We can actually do this little copying table here that I'll show you here in a minute or so. So I'm going to go through and I'm just going to show you what all the math is for this really quick. These are special right triangles. You did these in pre-algebra, algebra, and geometry, maybe even some algebra 2 as well. So I'm not going to go into great detail on this, but I'm going to at least show you the math and put in our numbers here. So I'm going to pause and put that in. Okay, so here's all the math for these. Here's our 30-degree angle right here. If you double that and think of this as this is basically an equilateral because it'd be 60, 60, 60 triangle here. If you simply double that here, all these sides are going to be 2. So since we cut this exactly in half, this side's going to be 1. And the same reason for this over here. So that's going to be 1. So we can do a squared plus b squared equals c squared. So we got a squared plus 1 squared equals 2 squared. And that simplifies down to a squared equals 3. And then we square root both sides. And that tells us that this side right here is going to be the square root of 3. Okay, same idea here, except for we've got a squared and b squared, but these are both the same. This has to be the same length as that. So we just said a squared plus a squared, which is 2a squared. Divide both sides by 2, square root it, and we get that both of these a sides should be root 2. Oops. And really, this is the exact same math that we did over here. It's just a different angle. So it's basically from this triangle, it's this angle over here. So we're still going to do a squared plus b squared equals c squared. And we're going to also get that this side here is root 3. Okay. So now if we're looking for sine of 30 degrees, that's the opposite over hypotenuse. So that's 1/2. If we're looking for sine of 45 degrees, opposite over hypotenuse is root 2 over 2. And then sine for 60 degrees, opposite over hypotenuse is root 3 over 2. Now back to the unit circle here. If we go for this right here, this is 90 degrees. So the opposite side, remember, is this piece here. As we go out to here, that's the opposite side. If we go all the way up to here, this length here is 1. And then this opposite side here, if you think of this little itty-bitty baby triangle here, this opposite side is also going to be 1. So that means that this is going to be 1. Okay? Now, at 90 degrees, 180 degrees, 270 degrees, all of these things are going to reflect. Meaning, this length right here for at, say, this at 60 degrees right here, we made this triangle, and we knew that this was root 3. And I know we put it over 2. It's just to make our simplifying a bit easier on this. So basically what happens is that this 60-degree angle is going to be the same as this 60-degree angle right here. Okay, which if you go to 90, and then that's another 30-degree angle, that's 120. So this and this side, root 3, these are both going to be root 3s right here. That's root 3, that's root 3. It mirror images each other. So the quick and easy way to do this is say, oh, I'm going to take this root 3 over 2, and I'm going to simply copy it down right over here. And then we can copy this root 2 over 2 goes down right here. So this is like a reflection line. This goes here, root 2 over 2 goes here. 1/2 goes here, and this 0 goes here. And now we've hit another reflection spot here. So this 1/2 is going to go here. But here's a little key. Once we cross through 0, because we're going to show you, I'm going to show you here, I'll just draw it up here really quick what the sine curve looks like. Here's what the sine curve looks like. So here's what we did. We just started at 0 and we went up all the way up to 1, which is right here at 90, and then down here we're at 0, and now we're going down underneath. So all of our y values are now going to be negative. So this is still going to get reflected, but now we're just going to add the negative sign onto it. Root 2 over 2 is going to go here. Root 3 over 2 is going to go here. And then this 1 is going to go here. But remember, all of these here have to be negatives. Okay, so we're down here. All these, the rest of these are still going to be negatives. We keep reflecting root 3 over 2, but it's negative. Root 2 over 2, negative, and then negative 1/2. And then this 0 gets copied back down there, which takes us up to right there. So this is this whole graph here. Okay, this whole, all these values here, just from coming up with these first pieces. Okay, I know we're running long. We'll polish this off and be done. So cosine, if we look at cosine over here, cosine is the adjacent side. So that's this side right here. So when we're out here at 0 degrees, that's going to be a length of 1, and the hypotenuse, adjacent side is going to be 1, hypotenuse is going to be 1. So this value right here is 1. Okay, really quick, I'll show you what the cosine curve looks like too. Okay, so here's what the cosine curve starts at 1. And then if we're looking at cosine of 30, that cosine is adjacent over hypotenuse. So that's going to be root 3 over 2. And for 45, adjacent over hypotenuse is root 2 over 2. And then for 60, it's adjacent over hypotenuse, 1 over 2. And then all the way up here, it's turned into 0 because there's 90 degrees. It's going right through here, right through this graph here at 0 because this length right here, right, because we're looking at the x value, this length right here is 0. So that ends up being 0. And now we can start copying across. Now notice it's all positive up here, and then from 90 degrees all the way up to 270 degrees, all the way up to here, everything's going to be negative. So basically whenever you get to a 0, we know that we have to switch the signs because it's now the graph's going from positive to negative or from negative to positive, and that works for sine and cosine. So we copy this over here, negative 1/2, negative root 2 over 2, negative root 3 over 2, and then this 1 gets copied down over here, but it's negative. And then we copy that straight across. It's still negative over here, negative root 3 over 2, negative root 2 over 2, negative 1/2. And then we copy down this 0 here, and now we're coming back up to the positive side. So we keep copying it, keep mirror imaging this here, 1/2 root 2 over 2. But all of these now are going to be positive because we're back up above the line, and we, the other trick is that we went through a 0 here. Okay, and then that's going to be 1. Okay, again, no, sorry, it's kind of long. Hopefully it at least made sense, and please feel free to ask any questions that you have in class. Thanks.